There is another scenario where function-based indexes turn out to be very useful, and this is when you want to index only a subset of rows. There are many tables that track things like requests, orders, applications, and the like. And usually on these tables, we'll have a value that will indicate the status of that item. For example, the application status column in the applications table used in the fictional university database that has been used throughout this course. In this simplified model, there are 4 potential values for this field, representing new applications yet to be reviewed, applications in the process of being reviewed, applications that have been accepted, and applications that have been denied. The nature of the data is such that over time, we'll have lots of historical data, meaning the bulk of the rows in this table will have a status of either A or D, representing historical applications that have already been processed. We'll have relatively few applications in the new or in process status because our admissions counselors will review these applications as they come in, making a disposition and accepting or denying enrollment to those students. From the perspective of our admissions counselors, though, it is these applications that are in new or in processing status that are really of interest. This is their work queue that tells them what they're currently working on and what applications need to be reviewed. So we can imagine a user interface that probably has some sort of data grid and lists out the new applications that need to be assigned out for review and the applications currently under review. But notice, these 2 status codes represent only a small fraction of our total data. If you have a system that tracks orders, you have a similar need in terms that the orders that you are most interested in are the orders that are unprocessed and waiting to be shipped. In a help desk ticketing system, again, you are most interested in the new and open tickets, not the historical tickets that have already been closed. In all of these scenarios, what we are really interested in is accessing and displaying some small subset of rows, whereas the vast majority of rows are in some sort of closed or completed status that isn't important to us, at least not for this use case. If we try to use a normal B-tree index, what Oracle is going to do is index all of the rows in the table. Consequently, this index is going to be relatively large on disk because we're indexing all of these rows. And we're going to have the overhead of maintaining the index for every row. So the problem is that we really want to index only a subset of rows, the subset of rows that we're interested in. And we can do this with a function-based index. In this case, the function we will use is the Oracle case function. And in the case function, we'll have the values that we want to index simply map to the value that they already are. But values that we don't want to index will map to a value of null. What this does is takes advantage of a property of B-tree indexes in Oracle, that if all of the values for a key in a B-tree index is null, then Oracle will not index the row. So let's see what this looks like in a create index statement. Here is the syntax for the create index statement, and the first thing that you notice is the case function that we have. What this is doing is mapping the values that are an N or a P to those same values. And then rows that have any other values are mapped to null. So in short, we map the values that we're interested in indexing to a meaningful value, and the rows we don't want to index get mapped to null. And then what Oracle will do is build an index over these mapped values. But as we said in the last slide, Oracle won't index null keys, so the result is that the index is built only over the rows of interest, in this case, our new and in-process application status values. The SQL statement to use this index would look like this. When we are using a function-based index, we have to have the same function in our where clause as we have in the index, so we see that same case statement again in the where clause. Now admittedly, this is not a very aesthetically pleasing SQL statement to look at with the case statement in the where clause. But again, this is really no different than what we did in the last section with the upper function. The important piece is that the function used here in the where clause of the SQL statement must match the function used to create the index. Otherwise, Oracle will not be able to match up the statement to the index, and the index won't get used. If the aesthetics of the SQL statement really bother you, you could always wrap the case statement in a user-defined function as shown here. If you do this, you need to make sure that first of all, you include the deterministic keyword in your function definition as shown here. Otherwise, Oracle will give you an error when you try to use this function to create a function-based index. And secondly, you need to make sure that this function is indeed deterministic. Just marking the function with the deterministic function does not do that for you. It's just a marker keyword. It is up to you to make sure that the function will always return the same value for a particular set of inputs, which in this case, it is pretty easy to see that it does. So if we decide to go the user-defined function route, now our create index statement and SQL statement will look like what you see on the slide. In this case, the SQL statement is a little cleaner to look at, and in that, it is less likely you'll make an error when typing this statement in. This also shows us that if we had some more complex logic, say for example the subset of rows we wanted to index was based on the values of two different columns, it's probably a good idea to encapsulate that logic into a user-defined function rather than coming up with some excessively complex SQL. And again, another benefit of this is that we'll have a much cleaner looking SQL statement that we can use in our application. Let's move into a demonstration of an index that indexes only a subset of rows so we can see this in action.